What's up, everyone? This is LeetCode 31 and next permutation. Okay, you can read this here. I'm just gonna allow you to do that because I don't want to make this video too long. But basically, as you can see by once you read this part, we basically have right. We basically have to sort the permutations according to their lexicographical order, and whatever array we're given, right? We need to basically get the next largest or the next greater permutation. If there is no next greater permutation, we basically have to return the lowest possible order, sorted in ascending order. So to me, kind of like I said, I didn't say this yet, but this problem is really hard. A lot of people generally think this problem kind of sucks. It kind of seems like you just have to sort. You don't have to sort these by lexicographical order, but conceptually, the way you think about it is, you have it sorted in a lexicographical order, and you have to get in the container. You have to get the next one. That's going to be your output, right? If you're like here, the next one, there is no next one, right? So you'd have to return, basically loop around and get the lowest one, which would just be the reverse, right? Conceptually, you can kind of think of it like that. That's not how we're going to approach the problem necessarily, but like conceptually, you can think of it kind of like that. We have to do this in place and use constant extra memory, right? Okay. Now this problem does kind of suck. A lot of people usually think that, I don't know if I mean, it's not, it sucks in the sense that this problem is very hard to solve if you've never seen it before. It's just one of those. So, I mean, I don't know, like, unless you've done a lot of permutation problems, I don't know how you could come up with a solution to this problem. Honestly, it'd be very difficult, in my opinion. But, basically, you can have three cases, which is what I'm going to use to break this problem down for you, right? We can have an increasing order, right? Like, example 1, we're given 1, 2, 3, right? And we would really just swap like the last two values because that would be the next greater permutation. And we have decreasing order, in which case there is no greater permutation, right? Like 3, 2, 1, there is no next greater permutation. So we're basically just returning that reverse in that case. And then we could also have a mixed case, which is like it's ascending order and then it's descending, right? We go 1, 3, 4, 9, and then all of a sudden we have a 7 and a 5, right? So this is kind of more the bulk of this problem. How we're gonna basically derive an algorithm to basically solve this, and our algorithm will basically handle these cases as well. Okay, so it's, in some ways, the solution's pretty. Even though this problem does suck in many ways, and people agree, I honestly think the solution to this problem is pretty cool because you can solve for this and this and this. I mean, with one algorithm, I don't know. I think it's pretty neat, right? So I just kind of broke these down into steps to try and explain how we're gonna solve this. So formulaically, how we're going to handle this is we're basically going to always start from the right side, right? We're going to start from the right side of the array with a pointer. Now, we're not going to set the pointer at the very last index. We're going to set it at the one before the last index because we're going to do this comparison here, which is nums of I and nums of I plus 1. So we don't want to start at the last index because we'd be out of bounds, right? So we're basically going to start at I of the last index minus 1, right? So it'd be right here. And what we're going to basically check if nums of I is less than nums of I plus 1. The reason is because when we're going from right to left, we should expect this to increase. Now, at the point where it decreases, right, that's basically what we can just call our pivot, and that's basically gonna be useful later on, okay? And I'll kind of explain this as we go, so it makes sense, okay? So we should be increasing, right? So we compare this 7 to this 5. 7 is not less than 5, so we move the pointer back and keep going. Is this 9 less than 7? No. Is this 4 less than 9? Yes, it is. Okay, so we found a case where nums of I is less than the I plus 1, right? And I guess more broadly, you can think of what we're asking is, yeah, well, never mind. We'll just stick to this just so I don't confuse you. So we found a case where 4 is less than 9, right? Well, 4 is less than 9 in this particular example, right? So we found a spot where this happened. Okay, now we need to set a different pointer, so we'll call it j. So I is right here at this 4. We're going to set a pointer at j, right? And we need to basically find a case where nums of j is greater than nums of I, right? And then we can do a swap. So when we set j at this 5, well, the i's here at this 4, right? So j at this 5 is going to swap with the 4, okay? Because when we find this, we're going to basically just do a swap with those values, okay? So the i's at the 4, we set j at the end of the, and again, the j is going to, like the i's is going to go from right to left, right? Until we satisfy this condition. Well, when we set the j here in this particular example, it already gets satisfied, right? Because 5 is bigger than 4. So we're going to do a swap. And then, by the way, the reason we have to do it like this is because we are finding the smallest permutation that is greater than the current one, right? So that's why we basically want to start from the right, because from right to left, it's we're handling the smallest numbers first, as we go from right to left. And that's why it's important, right? Because we want the smallest permutation that is greater than the current one. Okay, so after we do this swap with the 4 and the 5, right, we have something like this. Okay, now with this in mind, we want to reverse the array from I plus 1 until the end of the array. So we have this, right? Remember, the 4 and the 5 got swapped, so the I is right here at this 5. So we want to basically, this I'm highlighting here, we want to reverse this here, and we get 479, and that's our answer. Okay? And the neat part about this algorithm, it's going to handle the increasing order basically by swapping the last 2 values. It's going to handle the decreasing order by reversing the whole thing, and the mixed order case basically by formulaically and algorithmically handling what it needs to, as I just described up here. Okay. Like I said, this problem is not that pretty. It's very difficult to come up with on your own, the solution. And I'm going to show you this illustration because this helped me. This was in the solutions tab for the just written by LeetCode. They have a GIF here. I don't know if that's what you call it, GIF, whatever you pronounce it. Okay. So we're gonna find the first decreasing element, right? So, like I said, right? I don't know if I can pause this. No, I can't. But if I refresh it, it starts over. So from right to left, you see how it's increasing, right? We want to find the first case where the nums of I is less than nums of j, right? So here, this 4 is less than this 7 because this is I plus 1, right? So we found kind of, we can call it a pivot, whatever you want to call. People call it a pivot a lot in a lot of videos around the solution of this problem. So we can find this pivot. Okay, now we're going to set a j, we're going to find where the j, we're going to set a j at the end, and we're going to find where j is greater than I, okay? So our j should be this 5 here, okay? So we're going to find the 4, right? This is our pivot. So our I gets put here. The j, right, is going to be this 5, right? And I guess they went from left to right, but we're going right to left. I want to see what they did actually, because they went left to right. It's really interesting. Find a number just larger than 4, which would be the 5. And you see why they didn't take the 7 or the 6 is because, again, we want to find the smallest permutation, right? Right? Because if we're giving 1, 2, 3, for example, we don't want to return, anything bigger, right? We want to find the smallest permutation, which would be just the next one on the list of sorted container permutations, right? So that's why you don't want to take the 6 or the when we find this 4, that's why you don't want to take the 7 or the 6 for the j. You want to find the 5, right? That's why going from right to left is just easier. You don't have to add so you don't have to add logic for that. It's okay. So this is our I, right? Because nums of I is less than nums of I plus 1, right? So boom, that's where our j, they're doing from left to right, but we're going right to left. Either way, we find this 5, and then we swap the 5 and the 4. Now, this is where I is, right here, right? This is where I is right here, right? So we're going to swap with this 5. After these get swapped, I plus 1, boom. So from here forward, we're going to reverse everything. All of this is going to get reversed. Just watch after we swap, right? So look at this. Reverse, boom. Simple, right? That's our solution, right? Yeah. If you're, I think that makes sense to me, to be honest, the solution I just described. to solve this problem. You're welcome to go on LeetCode and read other solutions if you want like a more mathematical or understanding approach, but like a lot of people say the same thing. If you know the solution already, it's medium. If you don't, it's much harder. Yeah, this problem is quite confusing, honestly. Like I don't know how you'd solve this in an interview if you haven't done this problem before, but there's not a lot of intuition behind this problem. I mean, I'm sure there's some mathematical reason for how this problem works, but it is, I don't know. You're welcome to look it up, but to me this makes sense. It's just for like algorithmically how you would solve this, but in terms of the intuition behind it, I don't know. I mean, yeah. See, they're describing this problem here, and they're kind of just describing what I described, but like the actual intuition of why the solution works. I mean, I haven't really seen much information about this. If your interviewer asks you that, I think they just hate you, to be honest. But yeah, that's how we're gonna solve the problem, and it will work for this and this. Okay, so now let's get into the code. Okay, we're here in C++. That video that I recorded was for the Python video, but same logic will apply, obviously, just the code will be different, right? So remember the I pointer is not going to be at the last index, but one to the left of the last index because we're comparing nums of I to nums of I plus 1, right? So we're going to say int I is equal to nums.size, and instead of -1, we're going to do -2, right? And then here we need to do while I is greater than or equal to 0, and nums of I is greater than or equal to nums of I plus 1. We're going to do I minus minus. Okay. Basically, what we're just going to, all we're doing here is we're just decreasing the I pointer. If we are, as long as we're in bounds and as long as we haven't found this condition, or not that condition, sorry, as long as we haven't found this condition here and we're in bounds, we're going to keep going down. So we'll break out of this while loop when the I is less than 0 or when this condition is found or met. Then we'll break out of the while loop, okay? And we'll break out of that. And then we have another another condition here. We're going to say if I is greater than or equal to 0, meaning we're in bounds. So here, if I is greater than or equal to 0, it means we're not out of bounds yet, which means it means this condition was found and met, okay? Because we're still in bounds. So if we break out of the while loop, but we're in bounds still, I is greater than or equal to 0, then that means we must have found a case like this, okay? In which case, what do we want to do? We want to handle the stuff with the J pointer, right? So we're going to put the J pointer at the very end of the array. So we're going to say nums.size -1, right? And we're going to say while nums of J is less than or equal to nums of I, we're going to decrease the J variable. And again, we're just decreasing the J variable until what? Until we find this condition. When we find this condition, we're just breaking out of the while loop, right? It's very simple. That's all we're doing, right? Don't overcomplicate it. Sorry, I don't know if I tabbed or not. Apparently I did. Let's hope that works. I was just always taught to not use curly braces for one-liners and while loops and stuff, for loops, but I don't know, you can do it if you want. It doesn't really matter. I'll just do it this way just to keep it clean. Okay. So when we find this condition, a J that's greater than I, what do we need to do next, right? Right? We need to do the swap, correct? So for example, this 5 and this 5 is greater than this 4, so we need to swap these two values. Okay, so let's handle that. So after we break out of this while loop, this is really bugging me. It feels like it's on the same line, but it's not. This is Sorry, LeetCode's being a little strange. Whatever. Yeah, I can't get it aligned because technically it is not aligned. That's really annoying. Whatever. We'll just do this just because I don't want to have a syntax error later. Hey, it's not aligned. Maybe this isn't aligned actually. That's the problem. Sorry, I just noticed. There you go. It's that these weren't aligned. That's really goofy. Okay. Sorry, that might have been confusing fixing my syntax. So we'll go over what we have so far. Okay. So we set the I pointer to one to the left of the left pointer. Basically keep decreasing the I pointer until we find this, or until our I pointer is out of bounds as we go to the left. If the I pointer is in bounds still, it means we found this condition here, right? If we found this condition here, what does that mean? It means we need to set our J pointer, right? So we're going to set our J pointer, and we're going to basically keep going until we find where the nums of J is greater than nums of I. When we find where nums of J is greater than nums of I, we need to do a swap. So we're going to say swap nums of I. I think this is a built-in function in C++. If your interviewer hates you, they might make you implement it, but I mean, implementing swap functions isn't that hard. You just use a temp variable, right? I would hope you would know that if you're doing problems this hard. Otherwise, I don't even know how you would even get to medium problems. But okay, so when we're done there, that should be the end of the. This is a typo, sorry. Down here. Okay. Boom. When we're done here, we are going to basically call the reverse function on nums.begin, and this has to be all in place. So keep that in mind. That's why we have to do it this particular way to nums.end. Boom. Nums.reverse, and I think that should be it. Okay, and I'll explain obviously after we submit here, but this shouldn't really give us any problems. Submit and boom, perfect. Okay, so we have increasing order and decreasing order, right? Let's just quickly run through the increasing order. So if we have increasing order, right, we're gonna set the pointer. I guess I'll just do it down here. So if we have like 1, 2, 3, right, like example 1, we set the I pointer 1 to the left of the last index, right? And we compare nums of I to nums of I plus 1, and we stop when we're either out of bounds or nums of I is less than nums of I plus 1. Well, when we're here, nums of I is already less than nums of I plus 1, right? Because 2 is less than 3. So what do? We set a J pointer, right? So we would set it at the end here, and already the J pointer is greater than the I pointer in terms of values, right? Nums of I and nums of J. So we do the swap already. Boop, right? We do the swap, and there's nothing beyond this to really reverse, so we aren't really reversing anything, right? Because I plus 1, we're just reversing 3 with 3. I mean, okay, it's not gonna do anything. So we just basically do the swap, so we'd get this, and that'd be our final answer, right? So yeah. Now with the decreasing order one, what would happen, or descending order, I guess they call it. What would happen is, I get set here, so I is never less than I plus 1, because it's, as we go to the left, it's increasing. So nums of I would never be less than nums of I plus 1. So at some point, I is going to go out of bounds. So we break out of this while loop because at some point I is negative. And we never enter this if statement because I is negative. So all we do is the reverse from I plus 1. And if I is negative 1, we basically go from the 0th index to the end of the array, and we're swapping everything. And so that's why this works also for descending order inputs, right? Because if we have something like 3, 2, 1, we're just going to return 1, 2, 3. Okay, and as you can imagine, like I just explained this whole time, it'll work with mixed order type of problems by basically finding the pivot, swapping it with the j, and then reversing it from I+1 onwards. Okay, so yeah, that's how this problem works. I hope it helps. Like I said, I don't know if I said on this video. I think I said on the Python video. I forget sometimes, but this problem is just, it's a mess, and it's the intuition behind it's not that easy to understand. Maybe you can find some sort of mathematical explanation for why the solution works, but it just does work. It just does work. Because I mean, I don't even know how your interviewer would want you to explain this problem if they gave it to you. Maybe they would want, like, if you go on LeetCode, it'll show you this kind of notation, kind of how mathematically, I guess, it would work. I mean, it's not even really mathematic. It's just basically explaining how permutations would work. But I don't know. This problem is really hard to explain. I think it's easy to understand when you see the solution, but it's hard to understand or explain why it works, right? It just does, as far as I see. Yeah. A lot of people hate this problem, though. I wouldn't waste your time beating your head over it too much. Yeah, I don't usually curse on these videos, but like if you get this problem in an interview and they want you to explain why it works, I think your interviewer is, quite frankly, just an asshole. But yeah, I mean, there are solutions though, like on LeetCode here. If you want some explanation why this problem works the way it does, I'm sure you can find some mathematical explanation. Right, some like proof, a proof of why the problem works. But anyways, yeah, I hope this helped, and I'll see you all in the next one. Peace out.